In this section, we're going to be taking a look at a free response AP Calc question that's given a table, and this is kind of a very popular question that they like to do. And the reason why is there's different ways we can numerically approximate derivatives, numerically approximate integrals, and really do a lot of the stuff that we've done numerically. And you guys should know how to do it as we've done it in the past. And so let's go ahead and go through this problem. So for part A, let's go ahead and take a look at A first. So A says use the data in the table to estimate h prime of 6. Now notice the table is giving us h of t, so we're going to estimate the derivative. Well, we don't have a function, so we can't take the derivative of the function, but what we could do is find the slope, because remember the derivative is slope, and we're going to try to estimate this slope at the point 6. So using correct units, don't forget the second part. A lot of you guys need to forget the second part, and this is where you get full points. Using correct units, interpret the meaning of h prime of 6 in the context of this problem. So let's go ahead and find h prime of 6 first, or at least estimate it the best that we can. And there's a bunch of different ways and methods that we can use to estimate this. I'm going to go ahead and just find the slope between. Here's h prime of 6. Well, 6 falls right here, because notice the input is 6. So 6 would fall right there in between the 5 and the 7. So what we're going to do is we're going to go ahead and find the slope between the 5 and the 7. So h of 7 minus h of 5 over 7 minus 5. And what you really see there is y2 minus y1 over x2 minus x1. It's just the slope formula. It's fancy talk for that. So anyways, evaluating this gives us h of 7 is 11 minus 5 over 7 minus 5. And this equals 6 over 2. And my bad, hang on. I know where I made a mistake. I was thinking there's something a little bit off here. So it was 11 minus 6. That's a good thing this came up, though, because this is a common mistake. H of 5, I put 5, but actually h of 5 is 6. So that should be 6 there. So 11 minus 6 is 5 over 2. That looks a lot better. So what is this? If we're going to interpret this in the context, let's read what the problem is. So the height of a tree at time t is given by the twice differentiable function h. So h represents the height of the tree. Don't get too confused about twice differentiable. It just means that we could take the derivative not just once, but twice of this. So don't get too mixed up with these extra words. It's just kind of setting up stuff that we might see in the future that's really not too big of a deal. It's just, making sure it establishes it in the front. So the main thing here is that h represents the height of the tree. So what this means is that the height of the tree after 6, let's see, time is in years, so after 6 years, is increasing, because it's a positive rate, so you could say it's increasing at a rate of 5 over 2, and a rate needs to have some units. So what is this? This is meters in years, so meters per year. And that would be a perfectly reasonable response for that one.